Well, welcome. I'm very glad to be here in the first Hyperledger Global Forum. My name is Andrés Araya. I'm very happy that I won't explain what is blockchain for the very first time the last 2 years. Today is a very technical conference, but first, to start, I want to make an introduction of what we are and what we are doing in South America. The Santiago Exchange is the major exchange in Chile, and it's a 120 years old company. We are in South America. Chile is the most stable country in Latin America, economically speaking. We are a very open economy. We have more than 25 international trade agreements all around the world. That produces a very competitive economy. We are open, an open ecosystem for startup. Our government introduced a program for startup all around the world. Many developers and entrepreneurships come to our country. That's allowed a lot of interesting resources for doing new things. 2 weeks ago, we organized in the stock exchange a 100-years-old building, a hackathon, and we had more than 80 programmers developing all night long using Hyperledger and other frameworks. And what's very interesting, what they produce in one night. Our country is also recognized to produce a lot of copper. More than 30% of the copper around the world is produced in Chile. It's a nice place to visit. We have the dry desert in the north of Chile and a lot of rain in the south, very green. And in the center, we have a beautiful Andes. You can go to the ski in the morning and go to the beach in the afternoon. So nice place to visit. We have the major reserve of lithium that is nice for the future electric car industry. And we may be recognized daily by our fruits and our wine. Actually, in the COP supermarket, I could recognize some wines from Chile. Santiago Exchange is a multi-asset class exchange. We trade equities, fixed income, derivatives, etc. More than $3.5 billion a day trade, major in fixed income. And one interesting thing that we are mostly a technological company. More than 60% of our income sources come from products and services that we sell in the industry. As I mentioned before, we have a 125-years-old company. And in 2011, we created an international agreement with Mexico, Colombia, Peru, and Chile that called MILA Alliance. It's an Andean agreement. And we trade in real time with Peru, Colombia, and Mexico our stocks in real time. We are an open company, a public company. We trade in the stock exchange too. And for example, B3, who is the Brazilian stock exchange, has 10% of our company. And we are working with Hyperledger Fabric as a major fabric that we are produce software related to blockchain technology. As I told before, Santiago Exchange is a major technological company. 60% of the income comes from technological products and services that we provide to the different companies, especially brokerage houses in Chile. But now we are expanding to Peru and Colombia with back office services. Approximately 80% of the brokerage houses in Chile work with our back office services that we are created a vertical with SAP company to produce a back office services for them. As I mentioned before, the trading volume is $3.5 billion, mostly in money market and fixed income, and equity represent 3% of the trading volume for the Santiago Stock Exchange. And that's what we introduce the blockchain security lending. The security lending is useful for short sale. Short sale is when you think that an asset, the price of an asset will go down in the short term. And for example, if Marco has Apple security stocks and he is long, and I think that Apple go down in the short term, I lend from Marco that apples, and I sell in the market right now with Marco's Apple stocks. If something happened with Apple and my feeling is right and the price go down, then I buy back the Apple stock in the market and give it back to Marco, their Apple. So I get that capital gain with that short sales. That's how it's work. Obviously, Marco, to lend their stock, I have to sign a lot of contracts for collaterals or for many things, and that produce friction, back office frictions that allow that this market is small in Chile. It represents no more than 1% of the spot market in equities. The reason why is a friction back office services for what we have to do, and that appear the blockchain opportunity to facilitate that kind of transactions. When you start with a product services in blockchain, you have to select very well what kind of project you start with. One thing, especially in Chile, is the regulation. We are a regulated company, so if we wait for the regulator change the rules, forget about the law, you could wait 3 years for a startup project. So the project that you have to select doesn't have to change any rules in the market. And what we select, this kind of system. I want to little explain in the business side, because Marco will go into details of the technical side, how Santiago Exchange blockchain network looks like. When you start a project in a blockchain space, you can't wait that every single company that form your ecosystem adapt their own system to your new technology. So we have 3 use cases. The blue, the first brokerage houses, they are intensive in this market, short sales, so they don't want to invest anything to change their system. So we provide, through our terminal network, a graphic user interface, a web-based application, the input necessary to deal with the short sales if they want to go into. So they do nothing around this modification in this own system with the blockchain technology. The second case is the blue light, the second brokerage houses. They have their own back office services, and we created an API to interact from their own back office services with our own infrastructure. We create our own infrastructure on-premise and on cloud, approximately 6 nodes, because this kind of broker, they don't want to create their own peer, their own node. And the third one, the green one, the third brokerage houses, they want to go into the technology and they want to be part of this network because they want to modify their own back office services and introduce this new database, the centralized database, in their own back office services. And they do. We have clients that they do. And they, at the same time, create their own node, their own peer. Another important peer in this network is obviously Santiago Exchange, who act as an administrator. We are create a CA, a certificate authority, and we issue the certificate, that the invitation for the peers and institutional to work with this network. Another important peer is the regulator. Before that we launch this system, the regulators, if they want to do analytics, across the short sales market. They have to request information to the brokers and institutions, collect that TXT files, and after a week, they do the analysis. Now, they are doing almost in real time the analysis for this market. Another important period is institutional clients. Pension funds usually are the most lending institution that are allowed to lend, because usually they buy for long, so they are allowed to lend a lot of shares for the market. And to finalize this introduction from the business side of what we are doing, I want to explain a use case. When you start dealing with the short sales market, a client has to call to the brokerage house and for the very first time sign a master agreement. So in the old world, usually a client called to their broker and said, hey, I want to start dealing with short sales. The brokers have to sign a contract with me, the client, paper or digital, it doesn't matter, and he has to send to the stock exchange to verify the contract. The stock exchange type the information in the centralized systems and send it back if everything is okay to the brokerage houses. The brokerage houses type the same information in their centralized back office system and send to the client 4 days before. After that, okay, you are ready to deal with short sales. In the new world with blockchain, again, the client called to the brokerage house and say, hey, I want to deal with short sales. The brokerage houses write on the system using blockchain, using API, their own nodes, or our web-based application, write it in the blockchain, the contract, the blockchain system send to the client directly the contract, launched by the smart contract. The client signed the email and the contract, who is recorded in the blockchain, and that's it. They are allowed to deal with short sale market in less than 60 seconds. That's how we apply in one case, smart contract, our application. So now we are looking a little bit under the hood, how we built and how we launched this system in production with Marco Alarcon.
Thank you, Andrés, for making clear that Chile is not only a spicy sauce. So for the next 3 hours, sorry, no, we don't have that time. Well, for the remaining time before lunch, I will tell you a story. This story talks about how we built the blockchain lending repository starting from scratch. So let's go and check this. Okay, we started over there on January 2017 when we went to the IBM Team Garage located in New York for a full week with a suitcase full of probable business cases. There, we counted with the expertise of both technical and business consultants from IBM that were working at that time in the Hyperledger project. What was the idea? Is what to select a viable business case that we could use as a pilot to build a minimal viable project. To select this particular business case, we employed a scoring framework that was used at IBM. The main restriction, as Andrés said, was that we didn't need to change the regulation. Why? Because it takes a lot of time and sometimes a lot of money to do that. Okay, then we selected, in this case, the short sale as the problem to solve and move to blockchain. And after that, I assembled a small team of very capable developers experienced in end-to-end technologies. And in conjunction with a business analyst, I'm over there, we went to Baton Rouge, Louisiana, in the US, to work for a full month deep dive with an IBM development team. What we did that? Well, drink it a lot. No, my team, I don't drink. What we accomplished there was to do the analyzing, modeling, and designing of the basic of the lending repository. And we built the initial proof of concept for this system based on the same design. We had to do all the mock of the integration. It was a proof of concept, but the good part that was we got the skills necessary to keep going on our own to finish this product. Then we went back to Chile, and for the next months, we created the first network and the basic infrastructure for running this using containers. This was the first project in the exchange to use container technologies, and we used Docker. Why Docker? Because we are using Docker also. We use Docker Compose for our local environment, for our local development environment. That computer is my development environment. Okay, we did this integration that is not very exciting, but obviously is necessary. And we provisioned the production environment as an hybrid solution. As an hybrid solution, I mean cloud and on-premise. In June of this year, we went live, and right now, this system cannot be stopped, seriously. And what we are doing right now is adding support for bonds, for lending and borrowing bonds, and this is going live the next month, in January, using the same smart contract and the same infrastructure. Okay, this is how it looks like our lending repository based on blockchain. From a service perspective, first, as I mentioned it, we have to integrate all the legacy systems over there that were not migrated in the redesign of when we constructed the lending repository. In the backend system over there, we have the the matching engine, the trading system that generates information about the stock trades, in this case, short sales. And our matching engine is based on low latency messaging, asynchronous, with standard protocols of the industry like fixed protocols, and also surveillance and other systems. And also we needed to get to the current databases for custody and trading system to do query mainly for reports. Then we had also to interface with the pre-existing SOA platform that manage trading and custody information for things like stock prices, collaterals, etc. Okay, until here, this doesn't look like blockchain, right? Okay, over there, you can see the backend. This is the backend of the lending repository. This is a blockchain network based on Fabric. In this case, as Andrés mentioned, we are the owner of the network, and we are the one who decide who participates in this party, issuing the certificates. We are running the certificate authority, we create and distribute the certificates, and also we develop and deploy the smart contract for this network. We are running peer nodes for brokers that don't have their infrastructure and for no purpose. And all the order service is ours. We are using Kafka Zookeeper as the consensus algorithm right now. Okay, how you can access this platform? You have a collection of REST APIs built on Node.js that also include a specific Fabric client, a front-end user API, integration API for other systems like the Exchange ERP for brokerage houses, and also a task schedule that is based, on Jenkins CI. The idea down there is that the brokerage house can use this solution in a three-fashion way. One is with our current trading platform desktop client. The other one is that the brokers can integrate their back office system using the REST API. And for the desktop trading platform, we created a couple of HTML UIs and modified some of the pre-existing UIs to interface with the new APIs. And there, this solution requires also the displaying and signing the digital documents and send them by email. So we had to create all the required infrastructure. This is based on Jasper server and a client daemon for an email address, and a dedicated API for all document management function. And finally, down there, we have a participating brokerage house that is directly interconnected with our Fabric network. They created their own peer, and we interface them directly to our Fabric network using, in this case, a VPN connection. So, and we provided them a Node.js API, a client application, so they can use their own peer without having to invest in a steep curve of learning. All of this is based mainly on container technologies like Docker and Node.js for the API, HTML for the UIs, and Nginx for mediating all the requests. Okay, please memorize this diagram because I will show you only for the next second. It's very simple. Okay, now this is how our production environment is currently running from the network and the server perspective. Let's zoom it in. Here, we have the core of the system. It's blockchain. What we use it here is an overlay network based on Docker Swarm. Why Docker Swarm? As I mentioned it before, we are using Docker Compose for our development and QA environment, and Docker Swarm is like Kubernetes, a diet version. Okay, we have here an hybrid schema where we mix a couple of cloud servers. In this case is a Microsoft Azure, and our traditional data center back in Santiago. We have 2 data centers. We have provided in just one of them in GTD. And all of this, from the Docker perspective, is just a single overlay network, independent of the country where it's located. So I think that with this, I'm answering some questions that I heard yesterday. Yes, you can mix even countries in your blockchain solution. How latency affect this? Well, it depends on your business and operational requirements. And here, just for that, we are running in each Docker node many containers. Each container runs at least one peer, one world state database that is CouchDB, and we run all the order service in the cloud, because mainly for this solution, most servers are hosted in the cloud, so we wanted to optimize latency and throughput for the transactions. The peer nodes back in Chile are used mainly for 2 purposes. One is to do queries. We can integrate Power BI dashboards directly there. And it's for disaster recovery in case if we are in war with the US. I don't think that, but no one ever knows. We don't have oil. Thank you. Okay. Let's move on. We are running our own CA, our own certificate authority is Fabric CA. And we are running this in a high availability setup in an active passive cluster, because it's running with PostgreSQL that has to run in an active passive cluster. That's mainly why. We have created a 2-tier CA schema, one with the root CA that is always off. Well, not is always off, is on just when we created this network and then we shut it down. Why? Because after that, we created a couple of intermediate certificate authority, each for own participating organization. This is for security purposes, because if a particular certificate for, I don't know, a peer, an application, an admin application, a user application is compromised, you can revoke that particular certificate, or in a case that an organization had a security breach and all the certificates were compromised, we just revoke the intermediate certificate authority, but we don't compromise the whole network. Also, we have the server supporting the middleware service and APIs. In this case, it's an active-active cluster, and is in charge of running the Node.js Fabric Client API, Business Backend API, Task Scheduler, and Jasper Server for the document administration. It's important to mention that this cluster is never accessed by end users or UIs or other, directly by systems. This is mediated by the front-end APIs, by another set of APIs that are hosted there. So those are living in a separated VLAN, and this is like a DMZ, a demilitarized DMZ. And in this case, well, it's also an active-active cluster. Here you have the APIs for external integration for the trading UI platform, and both set of UI are quite similar. The main difference is how they store the user data and manage authentication and validation. All of this is based on Node.js APIs and is managed by PM2. And how we do the sizing? We took some dices, we throw them, and that was it. Now, for the Docker Swarm, here this is how the heavy lift work is done. We provided in Azure, we also tested for Amazon Web Service. A couple of weeks ago, we did an internal test to move a couple of peers to another cloud and interconnect two clouds also. We have 4 Linux servers in the middle tier available, 16 gigabyte RAMs, 4 virtual CPU, and in Chile, we provided in our current vCenter the same infrastructure. The only difference was the storage. For the middleware and the CA do almost no work. It's sleep almost all the time. And the middleware, since it runs many services, well, we had to provision a similar tier that we use it for the Fabric nodes. For the CA, we scaled it down, and also for the front-end APIs, because the front-end APIs are mainly, they do proxy functions for requests and store only authentication and user data. So all the CA and the front-end API don't require a very high-tier machine. Okay, this is the last diagram before lunch, please believe me. Here, the same thing, but from a logical perspective. You can imagine this like your common model view controller architecture. First, in the model layer, we have the blockchain peer and all the related stuff. So we created smart contracts to manage all the master service agreement, the short sales, the landings information, and a couple of general data smart contracts for utilitarian things like stock pricing, trading hours, etc. Since there is sensible information that the brokers don't want to share between them, it's their trade secrets, we have to create a multi-channel schema where we have a master channel that the regulator and the exchange can access, a general public channel that stores information like stock prices, and specific channels for the brokers where they can create transactions on their own behalf, and the stock exchange also can access and create transactions. Since we went live with Fabric 1.1, we didn't have the functionality of private data collection. So we had to be creative, and we created a channel replication daemon to orchestrate all of that. Moving up, between the layers, between the business and the model layer, we have a low-level set of APIs that are in charge of all the functionality of the peers, the channel, smart contract in general. It's an abstraction of the Fabric client. And over there, we have the controller. This is mainly an API that do business-related logic, use the low-level API to leverage the access to the network, and also has an admin controller that is in charge to administer the network, like creating the network, creating the channels with all the configuration, reconfigure channels, deploy smart contract, update smart contract, etc. And over there, we have how we access this. We have integration APIs, or in this case, the front-end APIs for the desktop trading platform. And this is mainly a decorator and aggregator API. The only thing that does mainly is adding the security. Finally, we have the UI views that is a mix between HTML5 for the new functionalities, like the Master Service Agreement Manager, and integrated functionalities like the lending management. Also, in this layer, we have access to all the common functionality that our trading desktop client can provide. So, we learned a lot of things, but this is a couple of lessons that I'd like that you take back home. First, when we were choosing in the phase 0, before starting the real project, you have to pick a suitable business case, right? Okay, don't try to do this alone by yourself. Get someone with experience. It sounds obvious. Hindsight is 20/20, right? Use it as a scoring framework, and most importantly, choose something that is a very quick win, but doesn't require regulatory changes. Then, when we did the deep dive, what we learned? Yes, we were in that building. First, for your human resources, prioritize quality over quantity. You can do this better with a small team of multifunctional developers and business analysts. Be agile. Use agile methodologies for your minimal viable project. Get business-aware developers. You need developers that understand the business domain. And you need functional business analysts that understand what blockchain is, because they don't have to migrate one-to-one your solution to blockchain. They have to reinvent your solution. Okay, this is not very exciting. Is the integration. What we learned, what we do, the full backend integration. First, it's obvious. It will take a lot of time, more than what you can think. And if you see that is a long-term effort, plan ahead and includes activities to do the upgrades between Fabric versions. They say that Fabric is retrocompatible. It's 99% correct, but there is always something that gets broken or changed or deprecated between versions. So plan ahead this. And also, if you have right now an existing SOA or microservice architecture, that is a very good thing that will help you a lot. Then, when we did the rollout, first, you have to provision your production environment. You have to choose. What will you do? You will go on-premise, you will go full cloud, or will do an hybrid solution like we did. You have to plan ahead a trial period, and you have to engage both your internal and external users. And this is really important, include stress and resistance tests that simulates high concurrency, because the developer is single-threaded in his mind. He will always think that he will test the system thinking in one user, using the UI and using all the functionalities. He never do a simulation with hundreds of users testing his function. And in this case, in a distributed system, it will explode. We have a couple of very bad nights fixing some code there. And also, if you have a blockchain network, you want to have a community, other participants, so their interconnection will be as low as their own telecom and your own telecom teams put together, because they always talk a different dialect of binary. And so get your external stakeholder, the other organization, and get a common schedule together to do the rollout. Okay, we have the system in production, and we want to do some things that in a traditional system we can do easily, right? We want to stop this. You cannot do that. It's in production and it's not going to stop. So we did a test to shut down 50% of the network, and the network keeps going on without problem. One of the things that is quite hilarious is from operational departments, they will ask you, please fix me a specific row in the database because a price is typed wrongly. You cannot do that here. You have to go through the smart contracts, right? And how you can explain to the operational teams or the audit team that you cannot do that and you cannot fix the price in a couple of seconds. You have to do a new release to add a functionality that allows you to fix that specific record, because your smart contract enforces new business rules. And also, well, this system will be as solid as the weakest component, because you have many cogs moving in this machine. And yes, your blockchain network will be solid, but you may depend on external or other systems that are not as solid as your blockchain network. Finally, to finalize this, a couple more lessons that you can take home. This is a paradigm shift, right? It's a distributed system. You need developers and analysts that think in a distributed way. The ledger setup can be really hard the first time. For us, was really hard because we started with Fabric 0.6 beta. And right now, it's more easy to do because you have templates for cloud providers, and you have already built up files for Docker Compose and Kubernetes. When we started last year, there was almost nothing like that. You need, as I mentioned it before, but I want to mention that again, you need a wide skill set team. You need developers that know security, network, a business analyst that knows the technology, that understands computer science. Other thing important, you want to migrate an existing product functionality. You cannot do that one-to-one. You cannot migrate your workflow exactly like it is right now. Innovate, think something new, like the process that we did for signing the master service agreement. Also, right now, the documentation of Fabric is top-notch. When we started, it was really close to zero. So we have to go directly to the source code. Sometimes, right now, the source code is as good as a documentation for something. For a computer scientist, it's better to read the source code sometimes than the documentation. Also, you will have problems that in your current system can easily solve getting the local machine time. In a blockchain solution, you cannot do that. You cannot ask system.time because a peer node will tell a value in Santiago. In US, we will have another value. In Singapore, we will have another value, and you cannot get to a consensus. So stochastic, random functions, time-based function, non-deterministic events, you have to eliminate that of your logic. Then, I hate that, the MVCC concurrence problem. You have to model thinking that in a single block, you can only update a single key, a specific key. You cannot do 2 updates over the same key in the same block. We had to learn that the hard way. And we have to refactor a whole smart contract because of that. So take that lesson because it will solve you many, many headaches. And finally, well, with this we wanted to test how CouchDB can be stressed, how can CouchDB can be used for all query-related functionality. We found that it has some limitations. Some are hard-coded directly in Fabric, and some are specific of CouchDB moving from SQL Server technology or SQL technology to a document-oriented technology. So you have to be creative with workarounds, compress data, create a binary index, etc. There is a lot of things that is not your day-to-day system. Okay, we have just 3 minutes for questions. Thank you for your time. If you want to contact me or Andrés.
Okay, I don't know if you have microphone. Yeah, let's go in there.
Do you have some figures? I mean, how many certificates? You have some key figures of your architecture. How many certificates? How many blocks? How many transactions?
I have that data, but not in this presentation. But you need at least for each. Well, you need the peer certificates, the order certificates. And for your applications, normally you need an admin and a user certificate also for your application. So that scales with the number of organizations.
Your question about number of nodes and transactions that we are currently running.
Yes. How many can you handle?
Yeah. We are working with 7 nodes, and 17 institutions are connected to this network. Institutions, not clients. There are many clients obviously connected, but institutions 17, and now we are signing more than 10,000 contracts from June to now.
Hello. Can I ask maybe a controversial question then? If you were to build this, would you choose a blockchain? And it seems like you're running the nodes in the same data center, right? So why blockchain?
Because it's a slow and expensive database.
Exactly.
No, we wanted to test the technology with a real business case and integrate that in the core of our system. We wanted to test if this technology was matured enough with this project. And we think that it's matured enough to solve some problems in the financial sector. Not all problems.
Let me add something. The problem in the financial area is mostly the reconciliation problem. So the clients, our clients, have back office services, and in the use case that we have, they have to type in their own centralized database, the same as the stock exchange, and that needs a lot of reconciliation usually. So when we move a node in the data center client, that is the case of this use case that we produce, The client, is the major bank in Chile, introduced their database for the stock exchange in their own system. So they cut a lot of integration that they have to reconcile information during the day. I just show one use case that produced that 4 days of complete the workflows moved to 60 seconds. But another smart contract produced that reduced reconciliation process that we have to do between the stock exchange and the brokerage houses usually during the day for this market. We started with this product that is slow product in terms of amount of transactions, but now we want to move to another use case. The equities represent 3% of the market, the 3 billion trading volume a day, but now we are moving to the bonds that represent the other $3 billion a day. I don't know if you answered the question.
Well, you're still hosting the nodes. You're still hosting the nodes in the same data center. There isn't.
No. No. We host.
Are they on premises?
No.
The clients.
On the we create a blockchain as a service infrastructure with our nodes on premise and in Azure to provide a service for the brokerage houses that don't want to create their own infrastructure, but is an option. Another option is create your own nodes. We provide a service. We create the infrastructure to provide service for monetize, a way to monetize our infrastructure to provide to the brokerage houses that do want to invest in their own infrastructure. But it's decentralized because
I understand how blockchain works.
Okay.
You don't need to explain. My question is, you're running a production system, I understand. And from the diagrams, it appears to me that all the nodes, Fabric nodes, are run in the same data center.
No.
So do they currently or currently not run in the same, in Azure, for example? Do you manage it? Do you host it on behalf of clients, or the clients host the nodes themselves?
Back to the network architecture.
And how many of them do manage the nodes themselves?
There are one client, a major bank in Chile, Banco de Chile, who runs appear in their own data center. That's the key proof of concept that the decentralized network.
Okay.
There are another one, assuming.
And they run and manage the node.
They own their own infrastructure.
By their own.
Here.
And we think that the most
this one.
useful case, that is Banco de Chile.
Yes.
It's the useful case because they trust in this infrastructure and they move away their own database and include in their own back office system this new decentralized database and avoid reconciliation process. Got it? Thank you. Another question?
We have just time.
Thank you for your presentation. Do you develop the chain code with a cross-development team from several stakeholders for the question of trust? And how do you include the regulator in the blockchain network? How do you convince and persuade stakeholders to have a peer for a question of cost? Because they secure the network. And do you reward participants which secure the network? Sorry, a lot of questions.
We did a lot of questions. So, for the technical aspects, the first one was the regulation, right? Yeah.
Well, you have. It's very important that you get on board the regulator. The regulator have very interesting in this technology, and as I mentioned before, they took more than 1 week to get the information of the blockchain and this kind of system to analyze the information, and they recognize that be a peer of this network, they could make that analyzed information in almost real time. So for them was a hit to connect to the network. So it was very if in that sense. I think that the regulator is the winner in this solution, definitely. I don't know. It's okay.
And
unfortunately, we are run out of time.
The cross-development team, Do you have your own development team?
Yeah, we built this solution with our own team. As Marco said before, they stay for 1 month in Baton Rouge, Louisiana, developing in conjunction with IBM team. We understand the technology with them, we understand the patterns, and they went back to Chile to continue the developing of the network. The most hard problem after the network is installed is to connect with the current system, with the legacy system, the trading system, the custody system, the back office services of brokerage houses, and create the infrastructure to connect with the network. Indeed, in 6 months, we finished the blockchain network, and the other 6 months is connect with the current system, and the other 6 months is dry runs and testing the infrastructure with the clients and get the onboard with the client with their own system with the new blockchain network. That's the pace of the project. Okay, thank you very much. I appreciate your being here.
Thank you.
Thank you.